So, welcome to Independent Thinkers on Digital, a series which tries to gain insight through some incisive dialogue with some of the world's leading independent thinkers on matters that are related to digital technology. I'm William Webb. I'm the CTO at Access Partnership, and very keen to cut through the hype with guests that will help me do that. And my guest today, I think, will absolutely do that. He is Professor Simon Saunders. Simon is an independent advisor and a researcher who's got deep industry and academic background in communication systems technology. His list of achievements is enormous, and I'm only going to pick a few here to highlight. But amongst other things, he's an honorary professor at the University of Bristol, an advisor to the Department of Science, Innovation and Technology in the UK. And he founded the Small Cell Forum in 2007 and chaired it until 2012, growing its membership from nothing to 150 companies. And it still exists today as an important entity to promote the interests of small cells around the world. He's acted as the Director of Emerging and Online Technologies for Ofcom. And at Google, he worked with operators globally in order to enhance their wireless connectivity. And so today we're going to talk about spectrum, and we're going to discuss whether we think there really is a shortage of spectrum or a scarcity of spectrum out there. And certainly, if you stand back and just look at the headlines that flow across the page, you would think that there is. Just a few days ago, for example, in the US, we saw the trade association there arguing that the mobile operators are going to be running out of 5G spectrum soon. I think if you dig into it at its heart, it's because they're using a lot of it for fixed wireless access, but nevertheless, a prediction that they will soon need more spectrum. And we see both operators and Wi-Fi enthusiasts fight over the upper 6 gigahertz band, again, with an indication that they both feel like they need more spectrum. And if you talk to almost any sector out there, the message you'll get back is we need more spectrum, with perhaps one or two exceptions, possibly the terrestrial broadcast community and others. But for the most part, there seems to be a strong demand for more spectrum. So, Simon, what's driving this, and why do we think that perhaps it's a bit too simplistic?
Great questions, William. So first of all, it's great to be here, and I love the title, Independent Thinkers. I strive to be an independent thinker, and you mentioned some of my affiliations and so on, and I just do want to stress that I'm not talking on behalf of anybody other than myself today. And spectrum's a fascinating topic, and we're going to spend the next 30 minutes or however long talking about it, and you and I have both spent decades, I suppose,
30 years at least. Yeah.
But just for some sort of context, on a day-to-day level, it's actually not that important, which may seem a slightly weird thing to say. But if you're a radio planner in a mobile operator, you're not thinking about what your license says or about the next spectrum band. You're working with the hand you're dealt, and you're trying to get the best from it, and that's kind of the most important thing. And likewise, though unarguably we can't do without spectrum in wireless communications and in a whole host of other wireless applications, because of course it's not only comms. Pretty much spectrum is stable over long periods of time. I've been doing some things with some IoT devices recently at 433 megahertz. There's tons of them out there. People barely realize it. It does really useful functions. It's never seen the light of a spectrum auction, delivers tons of value. So, sometimes I think we can get kind of over-indexed on how interesting this stuff is. And of course, we hear the most from those who feel as though they're hurting the most, which again gives a distorted picture. But yeah, this question of whether there's a scarcity of spectrum is a really, really interesting one, because, unarguably, you want the best spectrum. You want to be sure that the spectrum is there for the business you're setting up, or the application you're running, or the critical infrastructure that you're operating. And potentially quite subtle changes in the conditions and the location of that spectrum can really, really change the outcome for you. So it's going to seem quite, an act of hubris if we say, it's okay, there's no shortage of spectrum. But spectrum is a difficult thing. There are lots of subtleties, sort of technically and otherwise, to the way it works, and that means that people spend a lot of time trying to simplify spectrum. For example, for policymakers. And they produce these nice diagrams that show frequency along the axis, and then they put
Yeah.
on that a load of spectrum allocations, and it looks really, really crowded. And if you want some more spectrum for anything, it looks terribly difficult, and people have the impression that it's finite and scarce. Now, it is finite, no question about it. But whether it's scarce or not is another matter entirely. People use, for example, the property analogy, where you have the idea that all the good properties at the beachfront might have already gone, and you're going to be in trouble. And actually, it's a terrible analogy because it doesn't give a sense of the opportunity there is to make better use of spectrum over time, and for the many dimensions of spectrum that aren't just the frequency and what's allocated. We can think about time, about when different users have a need for their spectrum. We can think about space. We can think about where you need to use your spectrum. We can think about the technical details of how things are coded, because really frequency is just a way of separating different signals. And actually we know about lots of other ways, like codes and so on, for separating signals. Most of all, though, it's infinitely recyclable and reusable, kind of unlike property. I'd kind of like to advance the analogy of air as being better as a comparison spectrum than property, right? So in the main, we don't think of air as being scarce. It is finite. There's only so much air to go around, but we get to reuse it. And there are times and places where it's very scarce. If you're a deep sea diver, or you're in the centre of Mumbai at noon in the hot summer, it's going to be polluted, and you're going to suffer from that, and it's going to feel as though there's not enough air for you. But overall, there's more than enough to go around, and lots of opportunities to reuse it. So, with that rather abstract sort of thinking out the way, I think sort of fundamentally spectrum isn't actually scarce. What's difficult is artificial boundaries between services, some of which are of our own making. And these factors are changing substantially over time. So, spectrum regulation goes back to the 19th century, when our opportunity to be resilient against interference and to filter signals tightly and to cope with interference and noise was in a very different place to where we are now and where we can be in the future. And likewise, our ability to kind of administer access to that spectrum has come a long way. The auction houses of the past are supplanted by eBays of the present sort of thing. And spectrum can benefit from all of that. Now, look, demand still rises, and probably the story of wireless comms in the last 15 or 20 years particularly has been one of people talking about exponential growth. And so people say, well, you've got to have more spectrum to go with it. And I think there's another fallacy embedded in that, which is that, the amount of demand you have for wireless services has some kind of quasi-linear or even necessarily monotonically increasing relationship amount of spectrum that you need to serve that. And that's just not the case. For lots of reasons, we have different ways of accessing spectrum. We have more efficient ways of accessing spectrum. We have ways of reusing spectrum, and we can dig into all of these. And if we make best use of those, then I really think there is a potential future where spectrum is abundant. And what I mean by that isn't that that it's completely trivial to get to your spectrum, but I mean it was the case in the past that I think the hand you were dealt as an operator of spectrum was a prime determinant of the service you could offer. I think the potential for the future is that spectrum is no longer a constraint on the opportunities to build value socially or economically from it. We have enough ways and enough options that almost anything you can do is doable at some level.
So there's a couple of things I want to pick up on there that really interested me. One was the analogy question. And as you rightly say, spectrum has been compared to land for at least all the time I've been involved in spectrum. It's the classic analogy. And you can kind of see why it's done because it's so simple to sort of understand. But I agree with you. It hides a lot of complexities, and it might be steering us in the wrong direction. And I think the other issue is, as we both know, understanding spectrum is actually takes quite a long time, quite a lot of effort. You've got to understand the technical issues of how you use it, but also how you deploy it, some of the economics behind all of that, some of the means that it's regulated. It's not a simple thing that you can just tell somebody in half an hour, here's the whole story on how spectrum's managed. And yet we often see politicians and others sort of wanting to intervene in that space. And I think they probably do so with insufficient knowledge and perhaps with the wrong analogies, and hence get the wrong impression and go down the route of, well, we just got to carve out a block here, like we'd have to carve out a chunk of land and auction it off to that operator. And then you get some utterly bizarre things like the FCC at the moment is unable to conduct auctions because Congress has decided it's going to withhold that power until it gets the allocations that it wants out of the FCC. So it feels like there's something there. The other point I think you make, which I very much buy into, is that people often don't think about the unlicensed bands where there's an awful lot going on. And it's an example we've chatted about too, but it's worth sort of mentioning. Wi-Fi, of course, we all use a lot, and we use it as the mechanism of linking devices in our home. So pretty much everything that comes down our home broadband pipe ends up going over Wi-Fi in the home. And the home broadband usage is something like 100-fold more than the average cellular usage per month, sort of 50 to 100-fold. Now, there's a couple of people in the home, so you might say 20 to 40-fold or whatever. And that all goes across Wi-Fi, which has less spectrum than cellular. And almost everywhere it happens without congestion or significant issues. So it sort of does point to a different kind of future there. But how do we get there? How do we get to that world where the cellular operators aren't just saying, well, we can't deploy any more cells, it's too expensive, and we do move to a world where we either use more unlicensed or we start to think of spectrum more in that way?
Yeah. No, absolutely. Well, and first of all, you're right. It's not easy getting there, and holding up this ideal of long-term abundance doesn't mean that I'm blind to the complexities and the difficulties and the criticalities of getting that way. But a number of things sort of help here. So one is helping people understand the range of ways of getting to spectrum. As you say, big monolithic auctions get way more attention than license exempt or unlicensed spectrum, depending where you are in the world, relative to the value created, and helping people understand the richness of the options will be a helpful thing. One point is that those are treated like two sort of bipolar options, and that's all there is. You can have licensed, somewhat exclusive rights, and then you can have this kind of junky license exempt stuff. And actually, I think we have the opportunity to create a graded set of spectrum products, if you like, that have a almost infinitely variable level of protection and opportunity on them, which suit the wide range of applications. So when you mentioned small cell forum, and people would say when I was running that, okay, what are the categories of small cell, and define a microcell and a picocell for me. And I would say, go and stand on the top of a tall building in the middle of a city, look out over the range of buildings that you can see. That's how many different types of small cell we're going to need. And similarly, the range of things that you might do with wireless needs a very wide range of types of spectrum to access it. Another thing is that those maps I was talking about, where you have spectrum from DC to line, loads of allocations on top of them. But unfortunately, the world of spectrum policy and regulation is rife with an understanding of allocations and of licenses, and is very much more sparse with an understanding of actual usage. We need to bring what you're allowed to do much closer to what you actually need to do. If people have a license and sit on it and don't do anything with that, that's bad for everybody, probably themselves included, because they're paying for it. So we need to close the feedback loop between deciding what spectrum should be used for, what it's actually used for, and then how it gets changed over time. So we need to do some of that. And then another thing we can do, I think, we know there are at least three broad categories of ways of getting more demand into the available spectrum. One is more spectrum.
Yep.
One is with better technology that squeezes more into a unit of spectrum. And one is by reusing the spectrum more densely. And small cells are an example of that kind of densification. On the one around technology, it's tempting to think we've kind of run out of road on that one because, I think when you and I were first getting into wireless, we knew where Shannon's law sat and we knew where today's systems were, and squeezing another fraction of a dB closer to that was an exciting research topic.
Yeah.
These days, we're largely sitting, tolerably close to that limit. So you might think, well, what more can we do there? But it's all been applied to squeezing more out of the spectrum you're dealt. What hasn't been really applied, coexisting with your neighbours better. Partly because the incentives aren't there once you've got the spectrum. You're sitting pretty. But I think there is still more we can do about being interference resilient. And we should remember that we only need to regulate spectrum because of interference, which is harmful. This is written into United Nations treaties, that it's the presence of harmful interference that leads to the need for agreements on how to use spectrum. Harmful interference isn't actually a physical necessity. Signals propagating and reaching various places impact that do is entirely dependent on the technology that we use, the receiver technology, the demodulation technology, the beamforming technology, all of those sorts of things. And there are radio architectures which essentially abolish interference, where every little bit of signal that makes its way to a receiver somewhere is used constructively. They call various things comp and self-free network and these kinds of things. But just thinking about those fundamentals a little bit, I think can really help in plotting the path for the future.
And you and I both over the years kind of put forward and come up with all sorts of ideas that can achieve some of that. And I think we're pretty clear on what we'd need to do technologically, and it's not difficult. It's all within the grasp of today's technologies. It's probably more an issue of how do you get it introduced, and fundamentally for most of these things it requires the regulator, Ofcom or the FCC or whatever, to do something. And the reason that they often don't is not just because they can't be persuaded, but also because the stakeholders around them, as you said, are generally the incumbents who are sitting pretty on the current system, don't want to allow others in. How do we start to change that? It's a problem both of us have been grappling with for quite some time. And you've been involved with the government. I've been involved with Ofcom, the ITU, and others. Well, so have you with Ofcom. But I'm not sure we've cracked it yet, and we both, I think, got a number of scars to bear in times. But we've tried various things, like my spectrum usage rights ideas, that never quite managed to stick.
You're absolutely right. It's it's tough, and it will take time, and it's we've plotted a journey that lasts more than a century, and it's okay that it takes a while. I think there are reasons for some optimism, despite the scars. I think even those that are in the world of big monolithic auctions are starting to realise that I think we're coming to the end, actually, of the era when big monolithic auctions were the main way to go, for a number of reasons. One is that operators are increasingly disturbed about how much that involves spending, and aligning that with investment is challenging, and there are reasons why having them spend something is actually good for investment, but the numbers matter. But more sort of fundamentally, the sorts of spectrum we're dealing with doesn't deliver wide area coverage, is actually very large in terms of bandwidth, and big nationwide auctions don't make a lot of sense, combined with the fact that the moment at which you actually need that localized bit of spectrum may be very far from the point in time when you're asked whether you want the spectrum in an auction. So matching up that supply and demand is better done on a sort of just-in-time basis rather than in advance for the next decade. Who knows how many millimeter wave small cells an operator's going to need in
Yeah.
2035.
Yeah.
I can plot some curves, but it's no closer to the truth than anybody else's curve, I think. So I think many people feel that that big auctions still have their place, but they're not the go-to tool in the way that they once were. I listened to the discussion you were having with Ed Vaizey, and he said he talked about a previous auction, and he said, we made this happen, and there was little other choice. Actually, I think there are lots of choices now.
Yeah.
Lots of different ways.
Yeah.
We can help with that kind of thing. The other thing is I think automation. There are more or less exotic schemes that different people feel good or otherwise about: dynamic spectrum access, frequency sensing, cognitive, this, that, and the other. We can get into those, but the fundamental thing is we have automation. We need to get humans out of the loop of assessing pieces of paper to decide whether something is worthy of use. There comes a point where certain checks have to be made and so on, but on a day-to-day level, I should be able, on any piece of spectrum, to understand if there's an opportunity for me to get to that spectrum, on what terms, for what period of time, at what cost, what I can expect in terms of protection there, and to adjust, to automatically vary, given my demand, given my infrastructure, given the available spectrum, to make a good set of choices there. Not all of that needs to be down to the millisecond. In fact, very little of it does. There are exotic academic schemes for doing things at that sort of level. But I mean, that's not the timescale that infrastructure is built over. It can respond, it can change its parameters over those timescales. Bringing that information together would be very sensible. I mean, you could run eBay with people and pieces of paper, but why would you?
Yes. Yeah, absolutely. So I certainly agree with your premise that things that feel like they're changing. So in every previous era of cellular technology, as soon as people start talking about the next generation, the question has been, okay, so where are we going to get the spectrum from for this next generation? And then that discussion wends its way through the ITU and other entities and pops out at the other end, and you have the auctions. But of course, 6G is now on the horizon. But I'm hearing discussions of people saying, do we actually need more spectrum for 6G? Now, some say yes and some say no. But for the first time, there's some doubt in that question for some of the very good reasons you mentioned, that the spectrum would be at higher frequency anyway, which is of less use to the mobile operators. And where they've got some of this higher frequency spectrum, so where millimeter wave spectrum has been auctioned, it's generally not being used much. So it's hard to make the case that you need a whole load more of this at this point in time. So that does feel like a bit of a turning point where actually people are starting to say, well, maybe we don't need all of that spectrum or some new spectrum.
Yeah, I mean, I think that's true in a sort of qualified way. I've spent time very recently in the IMT 2030 process at ITU, and it's very much following conventional lines.
The old approach.
Terrestrial macro environment, and it's a new generation, so new spectrum will be needed, is the sort of tacit assumption right through that. But beyond those slightly rarefied and specific environments, I think that's right. I think there are some interesting things. So, new spectrum has been predicated on exponential growth, which was always somewhat suspect. If you actually look at the way mobile demand growth is continuing, the growth rates are slowing. It's still very substantial. I wouldn't want to belittle it, and the need to keep up with that is hard. It's hard for an operator to line up with that. But, conventional adoption curves, which are sigmoids, S curves, look like exponentials in the very early stages, and there is a sense that we're in the kind of mid-game now rather than the very early game. And maybe one day there will even be some leveling out. Either way, the equation shifts a little bit. On the other side, there are reasons why amounts of spectrum are needed that have nothing to do with the quantity of bits flowing through the network that are emerging, and in particular, I mean, the interest in 6G supporting sensing applications, or radar, as we would have called it upon a time. But when you've got to detect the location and the velocity and the timing of objects, then you intrinsically physically need a wide bandwidth, even if there's only one object that you're detecting, and you need high frequencies because of the spatial resolution that comes with a small wavelength. So quite interestingly, there's demand for large quantities of high frequency spectrum that have nothing to do with the quantity of demand. Flip side is it's only needed very locally, and it's only needed at very low power by comparison to our conventional expectations. But certainly, again, another reason why the the connection between users and demand, gigabytes per month and hertz of spectrum isn't looking like the straightforward story it used to be.
Yeah, it's a good point. So to go back to the point you were making about the ITU, do you think we should try and change the ITU, or do you think actually we should effectively bypass it through national regulators who show a bit more ability to innovate, and then once what they do is kind of clear and obvious, the ITU will follow suit, or what's the best route here?
Yeah, well, I'm pretty sanguine about the opportunities for changing processes in the ITU in any reasonable time scale. Things do change, do evolve, but over even longer time scales than typical spectrum award time scales. So I'm not I don't know if that's the best route for achieving the kind of change that we're talking about, but it will eventually catch up and reflect.
I think that's right.
Where I mean, I think the fact that we do have more flexible equipment. We do have more interference resilience. We are moving to higher frequencies. We are moving to higher densities. All points towards the opportunity to act locally. Thinking globally, to coin a phrase, that we can experiment and experiment in a scale commercial way at a more national level, while still respecting international boundaries and treaties, and then demonstrate how this kind of thing works. Something that makes it difficult for us in the UK to do that is scale. We don't have the kind of scale. I mean, if I were a large US operator and I decided a new frequency band was coming my way, I could persuade device manufacturers, or I could persuade 3GPP to add the band to standards and device manufacturers to support it inside 12 months.
Yes.
Couldn't remotely do that from the UK perspective, any of that. So that does create a challenge. On the other hand, the monolithic spectrum auctions that we were talking about before are also predicated on the assumption that there are huge barriers to entry in deploying mobile networks. Now, it's still expensive if you want to build a nationwide network, but not all networks need to be nationwide by any means. And, I put a 5G cell on a Raspberry Pi and made it work. And that didn't cost me any money at all. So, I'm not remotely suggesting that delivers the same kind of services, but just it means we can make quite advanced use of spectrum using quite advanced technology without having to work at the level of a international, multinational vendor or operator. And I think that will create the opportunities for innovation that will permeate more widely over time. It's really interesting to see now. I mean, there are relatively few operators that are mobile operators or fixed operators. So your point about Wi-Fi earlier on leads, national mobile operators to make a really big thing in advertising about how well their Wi-Fi works because they're using 6 gigahertz license exempt spectrum, which is kind of interesting, right? So it means that people have a wider portfolio of interest.
And I've seen that play out, and at a recent conference, Vodafone, for example, stood up and said, well, actually, we have both fixed and mobile networks in our portfolio. And on the mobile side, yes, we'd like some more spectrum for that. But on the fixed side, we want to make sure that the Wi-Fi on the end of our fiber to the home is working really well. And so actually, we would like to see something where both of those technologies can share the same spectrum, reuse it, and you can move between it, which makes obvious sense. I mean, it's from a technical point of view, it's a no-brainer, but from a commercial point of view, it's good to hear that kind of thing being said by companies like Vodafone, and it'd be great if others followed suit.
Exactly.
So I think I am somewhat optimistic. I look at CBRS in the US. I look at the Ofcom proposals, the 26 gigahertz auction here, which allow for both auctioning of spectrum, but also unlicensed or database-based usage around the edges of that. I look at things like the recent FCC proposal to allow shared use of satellites into mobile spectrum. I'm not sure that's necessarily quite the right way to go, but nevertheless, it's good to see that kind of thinking that allows different categories of use to get mixed up together in a way that shares, and in a way that's going to require some technological complexity behind it to manage all of that, which then gives us the kind of the assurance that it does work, which I'm sure it does. I have no doubt about that, but it demonstrates the scale that it does, and kind of starts people thinking in that direction.
I think you're absolutely right. I mean, you need. I mean, we've been talking about these things in a fairly abstract way, but we need these quite specific cases to drive that innovation. The converged operator one is a good one. I think inevitably we're now going to see in the upper 6 gigahertz different uses of it around the world, at least. Whether that
Yeah,
comes together into one country is another matter, but that's certainly happening. Another one is the advent of direct satellite to mobile, where you've inevitably got to be using the same spectrum for satellites and mobile base stations. Will drive that kind of thing. So I think that will force technology to be developed. We have to be careful it doesn't sort of these exotic processes that aren't seen as an end in themselves, right? I mean,
mm,
database driven access, for example, I think should be will in the end be the norm, not the
yeah,
exception. That doesn't mean that I think people should be scared that they can't build networks that have a lifetime of a decade, because if you do it smartly, you can have all of the certainty that you're used to having, and actually access to more spectrum than you'd otherwise get to. But the aim isn't database driven access. The aim is spectrum abundance and people being able to get to the spectrum they need. So I think these things are more likely to come along because somebody has a real need than because we think that there's an interesting way of experimenting with spectrum. And the other point there is not everything has to be the same, right?
yeah,
So it's not that you have to suddenly change the full edifice of spectrum policy and regulation overnight, but you do have to get busy on all of these methods in parallel. You need to find ways of bringing usage into the equation. You
mm,
need to find ways of
mm,
driving automated access. You need to not give up when it doesn't show rip roaring success the first time. White spaces, for example, is
yes,
quoted as a reason why you shouldn't be doing DSA, and it's like, well,
yeah,
just because one of these things didn't work doesn't tell you anything at all about the general principles.
yeah. We're getting close to the end of our time, unfortunately. But let me try and sum up what I think we've said. So um, I think both you and I are pretty clear that from a technological point of view, you can get vastly more out of the spectrum than we currently do, and that's through all sorts of things, but primarily potentially smaller cells and more sharing, more reuse, more dynamic kind of mixing of signals rather than just blocking out whole chunks of spectrum for various entities. It feels like we've been kind of saying this for a long time and coming up against multiple brick walls until recently. And I think rightly we've sort of said, well, there's a number of things going on here. One is the underlying nature of the demand is changing, and that offers opportunities. But also, there have been trials of these kind of things from TV whitespace through to CBRS and others, and they have been working. And it is kind of slowly creeping into people's sort of mentality that yes, this stuff might be able to do something, and there might be better ways to do it. And I sort of hope that um, it'll gather pace. So it'll feel a bit like, Coast suggested that auction should be used for spectrum, and then it took whatever it was, 20 or 30 years before they finally happened. And when they did happen, then fairly quickly after the first one, a lot of other countries jumped on it. Hopefully, it will pick up pace in the not too distant future, and we'll start to see some of this, and we'll start to see more of a world of abundance. But does that sound like the right kind of conclusion to you? Am I being too optimistic now?
No, I think that's broadly right. I don't think we should be in any under any illusions that this all happens fast. Although you're right, it probably won't happen smoothly. It'll happen in
Mm,
jumps and move ahead in some cases much faster than expected. I think there is a risk of seeing this too much from the point of view of a mobile network. So that's a very important
yeah.
part of the equation. But I think it is important to bear in mind the very various demands of radars and satellites and emergency networks and transport networks and so on, all of whom have different sort of constraints in there. And I also want to say that isn't, we're not trying to say that, well, I'm at least not trying to say that the sequence of kind of spectrum economics that you were outlining there was a dead end in any sense. Actually, in a certain sense, I want to go further with market-based regulation. It stopped at assignment. It didn't address allocation. Spectrum allocation, deciding which bands are good for which services and so on, is still a command and control process. And we have the opportunity to at least soften that, if not to do away with it, to mean that any spectrum could be for all sorts of things, and let's find a way that it can find its way to the best, the most valuable application for it.
That sounds like a great point to leave it. Simon, thank you. We could have talked for hours, but that was a fascinating, quick insight into spectrum and where we hope it will go in the future. Thank you very much.
Absolute pleasure, William.